Dear students, in the previous class we discussed about the different types of the crystal systems. Okay, I hope you remember the 7 different types of the crystals. It was, I think you remember, cubic, orthorhombic, tetragonal, hexagonal, monoclinic, okay, rhombohedral, and triclinic. Now, after we know the different dimension and parameters, so let me discuss today types of the unit cell. You know unit cell, as I show you the big diagram. So that's represented. I show you this is the like the unit cell. Here, the types of the unit cell or the type of the cubic crystal. Now here I choose the cubic crystal. As you know, the cubic crystal, what was the dimension and parameter? All these four sides are same and all these three angles are equal to 90 degree. Now here, what are the different types of the unit cell? Now number one, primitive or simple unit cell, or you can say simple cubic crystal. Number two, face center unit cell or face center cubic crystal. In short, we can write FCC. The number 3, body center unit cell or body center cubic crystal. Here also in short we write the BCC. Lastly, the type of the unit cell or cubic crystal here, and center unit cell or and center cubic crystal. So let me find, okay, let it be discussed. Okay, what are these different types of the unit cell? See here the simple unit cell. Look, this is the one of the unit cell. Just count it how many number of the corners are present. See in a box there are 8 corners. I hope you remember. Here in the simple unit cell, all the constituents, here the constituents, I think you remember, these constituents may be ions, maybe atoms, or maybe molecules. Okay, one of these constituents are present at all the corners of the unit cell. Here the corners are 8 corners. So these types of the unit cell we call the simple unit cell. Number 2, FCC. I already mentioned here. What is the full form of the FCC? Face center unit cell or face center cubic crystal. In FCC, the constituents are present at all 8 corners, as well as the 6 face center of the unit cell. 6 face center. See, I show you. In a box, there are 6 faces. Number 1, number 2, 3, 4, 5, 6. Now the center of the faces, we just say the face center. Here, 6 face center. So in the FCC, all the constituents are present at the corners as well as the face center. Corners means 8 corners. Face center, how many face centers? 6 face centers. These types of the unit cell we call FCC or face center cubic crystal. The third one is the BCC. What is the full form of the BCC? That is the body center unit cell or body center cubic crystal. Now in BCC, the constituents are also present at all the 8 corners. Now, as well as the one body center. See in a box, only one is center of this body, that is called body center. So here only one body center. So here the constituents are present at the 8 corners as well as the one body center. These types of the unit cells we call body center cubic crystal. The fourth one here I write Uncentered unit cell. Uncentered means, see I show you, this is the one of the face. So the alternate face of this one is this one. So here only we have the 2 and center and face. That means the center of this face we call a face center. Opposite of this face is this one, right? Now this center of this side and this center of this side we call ancenter or alternate face center. Now here in uncentered unit cell, so how is it? Constituents are also present at all the 8 corners as well as the 2 alternate face center. Remember these types of the unit cell we are called uncentered unit cell. Here I repeat it. These are the different types of the unit cell, how the constituents are arranged. So in the simple unit cell, constituents are present at all the corners. In the abscissa C, the constituents are present at the corners as well as 6 page center. In the BCC, the constituents are also present at corners and one body center. And lastly, the uncentered unit cell constituents are present at the 8 corners plus to the alternate faces. Okay, that means how many alternate faces? That is 2 alternate face center. Okay, you please remember. So this idea it's very important. Okay. Now let's we learn how to calculate the number of atoms per unit cell. Here, see, just remember, okay, we are going to calculate the number of atoms per unit cell. Per unit cell, alright, per unit cell. See, we can calculate the number of atoms per unit cell. Number 8, when the constituents are present at corners of the unit cell. And we can calculate the number of atoms per unit cell when the constituents are present at all the phase center. How many phase centers? 6 phase center. We can calculate the number of atoms per unit cell when the constituents are present at the one body center. I mean body center, we have only one body center. Already we know. Then we can calculate the number of the atoms per unit cell when the constituents are present at the n center. How many n center we have? 2 n centers. And one additional, here I just show you. So how many number of atoms per unit cell when the constituents are present at the S center. See here, S. Where is the edge of this box? See, so this is the one of the edge of this box. How many edges? So you can count it 1, 2, 3, 4. Then when you count it 4, 5, 6, 7, 8. Then one more here. Okay, 9, 10, 11, 12. There are 12 edges. Okay. So the center of the one of the edge, that is what we call edge center. So how many edge center? I show here 12 edge center. So we can calculate the number of atoms per unit cell in different position of the constituents were present here. See, now I started from number 1, number of atoms per unit cell. Here let us find out the constituent where present. Constituent when they are present at the 8 corners. See, I showed a very simple diagram. See, before that I just read this sentence. Its atom constituents. I said instead of constituent, I said atom. Atom present at the 8 corners can share with the 8 unit cells. See here. So look at this is the one of the constituents present at the corner. Okay. This is the one of the constituents present at the corner. So this constituents, how many unit cell can be shared? See, I show you. This is the one of the unit cell. Here we have one unit cell is here, and just behind this unit cell, one more unit cell is there. So I mark it here. This is the one. Another is this one. So this constituent, suppose I said atom. This atom now can share one of the unit cell. Another unit cell, just I mark it here 1 and 2. On other side, same number. So this unit cell can also share with this atom. Another constituent, another unit cell just behind this unit cell. That I mark it. This one is 3. This one is the 4. Now there are 4 unit cells. Just I drawn here above, just above these 4 unit cell. So another 4 unit cells are just placed here. See, one of the unit cell just I place here. That unit cell can share with this atom. This atom can share with that unit cell. I mark it here. This is the 5. Then one more just behind this unit cell. That is the 6. So and on other side same number of this unit cell we place here also. So one of the here and just behind another side. That is I mark it 7 and 8. So in our crystal, when we construct it, this is the smallest portion of the our crystal. This smallest portion constituents can be present at the corner. When the constituents are present at one of the corner, so how many unit cell can be shared? See, I just show you how many 8 unit cell can be shared. That's what I written here. Okay, now that mathematically I show you here. So contribution by atom present at 8 corners of the unit cell. So 1 is the atom which is present at the corner. This 8 is the number of the unit cell can share it. So this is the simple mathematical formula we can write it. So in our types of this unit cell, what is the type of unit cell? I mentioned simple unit cell. As you know, the simple unit cell, the constituents are present at the 8 corners of that unit cell. That atoms present at the corners. So how many number of atoms per unit cell? Just I read contribution by 8 atoms, because in the simple unit cell the constituents are occupied all the 8 corners. Therefore the number of atoms are 8. 8 atoms present at 8 corners of the unit cell. So this is the number of atoms which I make a circle. This is the number of atoms present at the corner, and one of the atoms present at the corner can share with the 8 unit cell. So 8 into 1 by 8 is equal to 1. This number is what is the number of atom per unit cell in the simple unit cell. So you remember this, okay? So here another number of atom per unit cell where the constituents are present. Constituents present at the 6 phase center. See, I show you the diagram here. This is the just simple diagram. See here we have a 2 unit cell. So one unit cell, I show you this matches box. Here, see the number of atom per unit cell where the constituents present at the 6 phase center. Now here I write its atom where it present at the phase center. Now here is the phase. This is the one of the phase of the one unit cell which I show here. So this center is just here. This is the constituents or atoms where it present at the phase center. So this one, when we place the one by one over the unit cell, the constituents which is present at the phase center can share with 2 unit cell. One is this, another one is this. So there are 2 unit cell. This constituent can be shared. So this is the number. Now here the contribution by atom present at the phase center of the unit cell. That's what I show here. One of the atoms present at the phase center. So these atoms can share with the 2 number of the unit cell. That's what I just write in simple way, 1 by 2. Now we have the another types of the unit cell, that is the FCC. What was the full form of the FCC? Phase center unit cell or phase center cubic crystal. Here, as we know before, constituents are present at all 8 corners, as well as 6 phase center of the unit cell. Now here we have to calculate in 2 different ways. See, the corners we already calculate in the just before this. So how was we calculate contribution by 8 atoms present at the 8 corners of the unit cell? We know 8 is the number of atoms present at the corners, multiplied by the one of the atom present at the corners can share with the 8 unit cell. That is 8 into 1 by 8 is equal to 1. This is the number of atom per unit cell, where the constituents are present at the corner. Now secondly, contribution by the 6 atoms, where the 6 atoms present at the phase center. So at the 6 phase center of the unit cell, 6 is the number of atoms here. So one of the atoms present at the phase center can share with the 2 number of the unit cell. So 6 into 1 by 2. So when we do the calculation, we found that is 3. So 3 is the number of atoms present at the face center. So now here, so in FCC, constituents are present at the corners as well as the face center. We do here number of atom per unit cell. This 1 from the corner, this 3 from the face center. Therefore 1 plus 3 is equal to 4. That is the number of atoms per unit cell in FCC. Remember it. Next, number of atoms per unit cell where the constituents present at the body center. So how many body center? Only one body center. So where is the body center? I just show you this simple diagram. Suppose this is the one of the unit cell. This is the one of the unit cell. So the constituents, just I make it darken here, this one. This is the constituents where the present inside the box of this unit cell, inside the box, okay, inside the unit cell. So this constituents present inside of unit cell. So this constituents cannot touch with the another box which we place here. This unit constituents cannot touch with the another box. What I mean that this constituents atoms is remain inside the unit cell. So here how we calculate number of atoms per unit cell where the constituents present at the body center. So atom present at the body center can share with no other unit cell. Can share with no other unit cell. Therefore the contribution by atom present at the body center of the unit cell is remain only one. Okay, that is the number of the unit cell. Now here the third types of the our unit cell, that is the BCC. What is the full form of the BCC? That is the body center cubic crystal or body center unit cell. Simply we can say. Now here, what was the BCC? As I mentioned before, constituents are present at all the corners. Corners, how many? 8 corners of the unit cell, as well as the body center. How many body center? We know only one body center. So when the constituents are present at all the 8 corners as well as the body center, how many number of atoms per unit cell in the BCC? We do the calculation here. See this part, I think we already learned from beginning. Contribution by 8 atoms present at the 8 corners of the unit cell, that is 8 number of atoms at the corner. One of the atoms present at the corners can share with the 8 number of the unit cell, that is 8 into 1 by 8 is equal to 1. But one of the constituents or atoms present at the body center, that atoms no other unit cells share it. Therefore the contribution by atoms present at the body center of the unit cell is remain only 1. So finally we find out that the number of atoms per unit cell in the BCC, that is 1 plus 1 is equal to 2. So remember this one. Next, after that, we know the number of atoms per unit cell where the constituents present at the corners, 6 face center and the body center. Now let's come to the constituents present at the end center. Here, end center, you know end center, as I said before, see one of this is the one of the face. The alternate face of this is this one. The alternate face of this one, right? How many alternate face we have? Only 2 alternate face, this one and this one. The center of this face, thus we can say face center. So the center of this and this center of this is the alternate face. So this alternate face we also know as end face. That's what we can say. So the center of this face we can say end center. So here how many end center we have? 2 end center. Now the constituents were present at the end center. So how many unit cell can share? One of the unit cell is here, another unit cell is here. Only 2 unit cell can be shared. So I mentioned here the number of atoms per unit cell where the constituents present at the end center. How many end center? 2 end center. Each atom present at the end center can share with 2 unit cell. That means I said 2. One is this side, another is this side. Now the contribution by atom present at the end center of unit cell. Here I said this one is the number of the atom present at the 1k end center. So this is the number of the unit cell, that is we can write 1 by 2. So here if we calculate the number of atom per unit cell where the constituents present at the end center, so the number of end center is here 2, then 1 is the number of atoms present at one end center and divided by the number of the unit cell, that is 2 into 1 by 2 is equal to 1. So that we keep it remember. Now here the third type of the unit cell we already mentioned, that was the end center unit cell. We are going to calculate the number of atoms per unit cell in the end center unit cell. How we do calculate? As we know, the constituents are present at all the corners. See here the types of the unit cell. So all the constituents always present at the corners, right? As well as the two end centers so of the unit cell. Here how we do the calculation. This part I think from the beginning we learned the contribution by the 8 atoms present at the 8 corners of the unit cell. So we do the calculation 8 into 1 8, 1 by 8 is equal to 1. In the case of the constituents present at the end center, so how we do calculate contribution by 2 atoms, because we have a 2 atom present at the 2 end center of the unit cell. We do the calculation 2 into 1 by 2 is equal to 1. Now here is the number of atoms per unit cell in end center unit cell, that is number of atoms per unit cell, this one from the corner, this one from the end center. So 1 plus 1 is equal to 2, that is the number of atoms per unit cell. Okay, the last one is the number of atoms per unit cell where the constituents present at the A center. So already we know how many number of the A's. So in our unit cell, suppose this is the unit cell, how many A's? I already show you there are 12 A's. The center of the A's that we call A center. There are 12 A center. When the constituents are present at all A center. So how to calculate the number of atoms per unit cell? See, remember when we discuss about the types of the unit cell, there are only 4 types of the unit cell. So this last part is not included in our types of the unit cell. Don't forget. Only for our case, another purpose, we need to calculate the number of atoms per unit cell where the constituents present at the 12 A center. See here, I show you. Now in my diagram, I think okay, you may have some problem to clarify, you may have some problem to understanding, but in a very simple way, so I just mentioned here. Here there are 4 unit cell. I just arranging over by over. Here how it just I show you. This is the one of the A's of the one of the K unit cell. So this center what we call A center. The constituents present this at this S center. So how many unit cell can share? Number 1, this one. And just above this unit cell I arrange another unit cell that we can share this. Okay, atoms can share with this too. And on the other side, same number of this unit cell can also arranging here. One is here, another is here. Therefore, what we can conclude that, so these constituents were present at the S center can share with the 4 number of the K unit cell. Therefore, I write here each atom present at the S center can share with the 4 unit cell. So after we know the number of the K unit cell can share, so how many contribution of the atom present? Contribution by atom present at the S center of the unit cell. This is the atom where the S center present. Then this number 4 is the number of the unit cell. Therefore, we just express in a very simplest formula 1 by 4. Now here, since we have the 12th number of the A center, so if all the atoms are present at the all the A centers, how many atoms should be there? 12 atoms. Suppose we have 12 atoms. How many numbers we can be contributed? Contribution by the 12 atoms present at the 12 S center of the unit cell. one of the simplest expression, already one atom can share with the 4 unit cell. So how many atoms are here? 12 atoms. 12 atoms into 1 of atoms can be shared with the 4. That is 3. This 3 is the number of the atoms per unit cell. This is the number of atoms per unit cell when we do the calculation in the center, right? So please remember how to calculate the number of atoms per unit cell where the constituents are present in different position. By using that number of these atoms, so we can find out the how many number of the atoms present in our crystal. So from that number we can learn how to write the formula of the compounds present in our crystal. Keep remember these things.